Welcome to Spelling Bee Ninja, where we strive to empower learners with the knowledge they need to succeed. If you're eager to discover engaging educational content that makes learning enjoyable and accessible, subscribe to our podcast. Join our community of curious minds, and let us support you on your journey of knowledge. Today, we're going to explore the fascinating world of angles and shapes, delving into geometry concepts that are fundamental in understanding the world around us. Geometry isn't just about abstract shapes and numbers, it's about making sense of space, design, and even nature. Let's start with angles. An angle represents the rotation between two intersecting lines, and it's measured in degrees. There are various types of angles, and understanding their relationships is crucial. For example, two angles are considered complementary when their measures add up to 90 degrees. Picture this as pieces that complete a right-angled corner. On the other hand, two angles are supplementary if they total 180 degrees, which you can think of as two angles that together supply a straight angle. This understanding leads us to a practical application. If an angle measures 35 degrees, we can determine its complement and supplement effortlessly. Its complement would be 55 degrees, while its supplement is 145 degrees. Keeping these relationships in mind is essential in various fields, including architecture and design, where angles play a critical role. Next, let's discuss vertical angles. Vertical angles occur when two lines cross, creating angles opposite each other at the intersection. A key property of vertical angles is their equality, they are always the same measure. Visualize an X shape with lines crossing. The angles at the top and bottom are vertical to one another, just as those on the left and right are. For instance, if one angle measures 72 degrees, its vertical counterpart also measures 72 degrees. Understanding vertical angles is vital for solving complex problems in geometry. Moving on, we have adjacent angles. These are angles that share a common vertex and side but do not overlap. Imagine two pizza slices next to each other sharing a crust, which is the common side, and meeting at the tip, known as the common vertex. Adjacent angles can be identified easily, but it's important to remember they are not overlapping and are distinct from vertical angles. Clarifying these aspects of geometry aids in more advanced studies, including trigonometry. Let's not forget about transversals, a term used when a line crosses two parallel lines. This creates 8 angles, each with specific relationships. For instance, corresponding angles sit in the same position at each intersection and are equal. Alternate interior angles reside inside the parallel lines but on opposite sides of the transversal and are also equal. In contrast, consecutive interior angles, which are inside on the same side, are supplementary, together forming 180 degrees. Grasping these concepts helps you navigate through geometry more effectively. The interior angle sum of polygons is another fundamental aspect to master. Each polygon, which is a closed shape with straight sides, has a characteristic sum of interior angles. For a triangle, that total is 180 degrees, while for a quadrilateral, it is 360 degrees. More generally, if we have a polygon with n sides, the sum of interior angles is given by the formula, n2 times 180. For example, if we consider a pentagon, which has 5 sides, we can calculate its interior angle sum as 360 degrees. Mastering these calculations provides a solid foundation for complex geometric problems. Have you ever thought about regular polygons? These shapes not only have equal sides but also equal angles. Take a square, for example, which is a regular quadrilateral with each side the same length and every angle measuring 90 degrees. Similarly, an equilateral triangle is a regular triangle with all angles equal to 60 degrees. To find each interior angle of any regular polygon, the total angle sum is divided by the number of sides. This is a key principle to understand, especially when working with octagons, which have 8 sides. Knowing that each interior angle in a regular octagon measures 145 degrees helps in various applications, especially when referring to design and architecture. Now let's dive into a specific approximated shape known as a parallelogram. This is a quadrilateral with both pairs of opposite sides parallel, which yields some interesting properties. Parallelograms like rectangles, squares, and rhombuses all share these characteristics: opposite sides are equal, opposite angles are equal, and adjacent angles are supplementary. Imagine a parallelogram marked ABCD. If angle A measures 110 degrees, we can swiftly identify angle C, its opposite counterpart, also measuring 110 degrees. This knowledge becomes increasingly important in real-world applications, such as in construction and engineering. Rectangles, unique among parallelograms, not only have these properties but also contain 4 right angles. Because of their parallelogram nature, they also have opposite sides that are equal and parallel. Furthermore, diagonal lines in rectangles bisect each other, and they hold a special property where their diagonals are congruent, that is, equal in length. For instance, if you have a rectangle with a length of 6 cm and a width of 8 cm, we can apply the Pythagorean theorem to find the length of each diagonal. This exploration of lengths leads us into the realm of circles. Circles are among the most basic yet essential shapes in geometry. A circle can be defined as a set of all points at a fixed distance, known as the radius, from a central point. Measurements related to circles are crucial. The diameter stretches across the circle through its center and is double the radius, while the circumference measures the distance around the circle, calculated as pi times the diameter or 2 times pi times the radius. Additionally, the area inside a circle can be found with the formula pi times the radius squared. To apply these formulas, imagine a circle with a radius of 7 centimeters. Using the approximation pi equals 3.14, we can calculate its circumference as approximately 44.08 centimeters. Finally, let's talk about triangles, which have a unique relationship between interior and exterior angles. An exterior angle is created by extending one side of a triangle. The exterior angle theorem tells us that the measure of an exterior angle is equal to the sum of the measures of the 2 remote interior angles, or angles that are not adjacent to it. For example, if in a triangle one interior angle measures 50 degrees while another measures 70 degrees, we can calculate the exterior angle adjacent to the third angle, using either the knowledge of interior angles or directly applying the theorem. This theorem is crucial for identifying various unknown angles in geometry and can be particularly useful in fields like architecture and engineering, where understanding angles and their relationships is necessary for design and construction. Today, we journeyed through the world of geometry, focusing on the relationships between angles and the properties of various shapes. We learned about complementary and supplementary angles, discovered the importance of vertical and adjacent angles, and engaged with transversals and the interior angle sums of polygons. Moreover, we explored the characteristics of regular polygons, parallelograms, rectangles, and circles, while also applying the exterior angle theorem to understand the connections among angles in triangles. These concepts are not only foundational for geometry but also essential for practical applications. Thank you for joining us on this enlightening exploration of angles and shapes. We hope this episode sparked your interest in geometry and provided you with tools to understand and apply these concepts in real-world situations. Remember, geometry is all around us, enriching our lives in ways we might not often consider. Until next time, keep questioning and exploring the wonderful world of mathematics.